Hello, my name is Rob Reynolds. Welcome to Calculus section 3.5. We're going to be looking at taking derivatives of trig functions and in this video. And before we begin, we're going to review something that I introduced on a previous video that talked about taking the limit of sine x over x. And here's the graph of sine x over x. And you can see the limit as it approaches from the left and as it approaches from the right, it equals 1. Now, be careful. I'm not saying that there's a trig identity that equals 1. That's not true. But when you add this limit as x approaches 0, then it's true. It's at 1. But the function is actually undefined because you can't throw in a 0. So similarly, we have another limit that oftentimes comes forward. And then the question is, do you need to memorize these or not? And the answer is, well, at least recognize them so that when you run across, especially this one, very common, but just recognize it that the sine x over x goes to 1, where cosine x minus 1 over x, as the limit approaches x equals 0, go to 0. And again, the graph might help you remember. So let me work out a problem that we can use those two definitions. So for this first one, to try to fit, and that was this cow divided by a cow, I got to get this cow to be equal to this cow. Well, so let me back up here. So it's kind of the form that I'm talking about, the form that needs to be in. Wolfram Alpha sometimes is a very helpful tool. And so I asked it to find the derivative of this quotient, 4x divided by, and then there's the low. And the last video we talked about low d high minus high d low in section 3.4. On MyMathLab took this as a solution, and I'm just saying, when you take your test, your written test, I'm not a big fan of a solution like this because it can be simplified. I want this for the final answer. So if you were to leave your final answer, even though MyMathLab is accepting answers that are unsimplified like 2/4, I really would prefer you to simplify 1/2. And the reason is that some people will try to simplify and then get it wrong. And then what do I do with the people who don't even try to simplify? I don't know if I can justify that they get 100% because they didn't even try. So to try to get it into the correct form, we need to create a 4x down here. And we can do that by multiplying top and bottom by 4. Well, I'm going to pop this 4 way out front. And it's 4 then times the limit of x approaches 0 of sine x. 4x stays there. That's this 4x. And then this down below is 4x. And so now we have 4 times, well, here comes the definition. The limit of that, according to this definition, equals 1. And the answer is just 4. It's a little bit harder for this problem. Just so that it makes a little bit more sense, I'm going to break it up into 2 steps. The first step is I'm just going to divide the top and divide the bottom by x. I could do this all in one step, but I think you'll see it better if I break this up. The sine of 5x divided by x. Remember, whatever you do to the numerator, you have to do to the denominator. So now I need to create some 3. So 3 divided by 3 up in the numerator is a 1, and 5 divided by 5 is a 1, and what's nice about that is everything here in green goes to 1, and everything here in blue goes to 1, because again, I'm working for that sine cow over cow business, as the limit as long as it's going to 0, which it is. I didn't write it, but I should. The limit as x approaches 0. So all of this is going to be 3 times 1 over 5 times 1, or just 3/5. So just like we got, 4 was the first answer and 3/5 was the second answer. This slide is your first look at the derivative of sine x. And here's again, the limit process, which we learned in section 3.1, f of x plus h minus f of x all divided by h. And if you're interested in knowing why the derivative of sine x is cosine x. There it is for you. I've worked it out, but from this day forward, if y is sine x, I would recommend that you just memorize that the derivative is cosine x. So, and the derivative of cosine is going to be negative sine. Again, I'm not going to derive that for you. I'm going to spend time on this video kind of showing you some examples, but we can certainly go through and derive those for you if you'd like. So I'm going to use the product rule and some derivatives of trigs here. We learned in an earlier video 1d2 plus 2d1. So there's 1. d2, the derivative of cosine, well, one of the ways I kind of remember it is the c stands for change, and we are going to change the sign from positive to negative. So every time I see a c, I just remember that I'm going to change it. A little memory aid. So 1d2 plus 2d1. Okay, so the derivative we learned earlier of e to the 2x is e to the 2x, but then I need to multiply by du, and I'm going to do a little u sub. Remember, I'm going to let u equal 2x, and then du would be the 2, so it actually comes out to be 2e to the 2x. So that's a little bit of chain rule that I threw at you that we don't really get until maybe section 3.7. But I like introducing those u's and du's early. The more you see them, the more successful you'll be with them. So now the question is, I wonder if I could factor anything, because you know Mr. Reynolds likes things in factored forms, and I do see an e to the 2x. Looks like it can come out of this thing. So e to the 2x times the quantity. Oh, I'll probably put the minus sine x second, just because it looks a little bit cleaner. Don't have to do that. And then this looks like a 2 cosine x. In part B, I wonder if I can just shrink this or move this real quick. Shrink it down a little bit, and then maybe ungroup it so I can see again. Highlighter for some reason acts funny when I group things together. So here we go. The derivative of sine is cosine. And then all of a sudden I run across a product in here. So I'm going to do that 1d2 plus 2d1. So 1 d2, the derivative of cosine is negative sine, plus 2, the second function is cosine, d1. Well, that's just a 1. And I'll try to clean this up. But before I do, I better make sure I understand what that negative applies to. And I need these green, so when I distribute this, I have to distribute it here too. So this is really positive cosine, and this, after I distribute the negative, that's a negative cosine. And then everyone's going to get this right. Negative times negative is positive, so it's x sine x. But you understand that this will cancel with that, because, yeah, I'm going to distribute over this addition sign to every term. The last example, I'm actually going to do low d high, the quotient rule. So it's a low d high. Okay, well, the derivative of 1 is 0. The derivative of sine is cosine. Low d high minus high, 1 plus sine x d low. So the derivative of negative sine is negative cosine. Ran out of room. All over low squared. I see some things that I could maybe factor out of cosine x, but I'm just going to just multiply it out because most of you feel comfortable multiplying things out instead of factoring. So cosine x minus sine x cosine x. Ooh, let's see. I'm going to distribute this, so it's negative cosine x minus sine x cosine x, but when I distribute this negative, it's plus cosine x plus sine x cosine x. And it looks like this cosine x does not cancel, but the negative sine x cosine x with this positive cosine x does. And I think I have an answer now, maybe of 2 cosine x's over the common denominator. Let's see what the author says here. Yeah, 2 cosine x over the 1 minus sine squared x. So we don't know yet the derivative of tangent, so I'll work it out. I know that tangent can be defined as sine x over cosine x. So I'll do low d high because it says show the work. And we don't know the derivative yet, so we can't use the derivative of tangent. I'll do it low d high, the derivative of sine. Oof, and went quacko there. Is cosine low d high minus high. The derivative of the low is negative sine all over low squared. So let's see, this is cosine. I might need to know some trig identities here. Whoa, what's cosine squared plus sine squared? Well, that's one of the most important trig identities. I hope you know that as 1 because of this is cosine theta, this is sine theta, and we use the unit circle. A squared plus b squared equals c squared. It's a unit circle, that's a 1. And 1 over cosine, perhaps you know that as secant squared. So from this day forward, never show that to me again. Just memorize the tangent goes to secant squared. One of the ways that I kind of memorize that is there's a trig identity that's similar to this, and it's 1 plus tangent squared theta equals secant squared theta. So always kind of remember, in fact, if you watched that video previously, I called it the 1 plus 1 rule is second base, kind of the way that I'm just memorized that trig identity. But 1 plus tangent squared is secant squared. I know that tangent has asymptotes at your half pi's, pi over 2 and 3 pi over 2, and guess what? Secant does too. Same. So there's a strong relationship between tangent squared and secant squared. There's trig identities. The asymptote graphs look the same, and now we've learned that the derivative of tangent is secant squared. So however you get these memorized, use flashcards, use whatever you can, but I don't want you to have to work through this ever again, unless it says to derive it. In the future, if I ask for the tangent, derivative of the tangent, I hope you can just memorize it and give me secant squared. There's other patterns in here that I kind of just want you to memorize. I've already shared this rule. If it starts with the letter C, you change the sign, and that's true for cotangent. And perhaps you remember that 1 plus cotangent squared theta equals cosecant squared theta. And C is the third letter of the alphabet, and so it has 3 asymptotes when you go graph them at 0, pi, and 2 pi. So again, just memory aids. And again, I don't know if this makes sense, but 1 plus 1 is 2 C's. However you memorize it, it's fine with me. But I also memorize that every time you take the derivative of a C, what happens? It goes negative, and that's true for cosecant. So from this day forward, we haven't looked at it yet. We haven't derived it for you, but I'm telling you, the derivative of cosecant is negative cosecant. Well, why is it negative? Because it starts with C, and it's cosecant because it's, and then it's a cotangent. And secant does the same thing. The derivative of secant is secant. That's kind of nice. The derivative of cosecant is cosecant. And then there's some more. And then the derivative of secant is secant. And then there's some more. So look for some patterns and whatever makes sense to you to memorize these things. One pattern that I absolutely love is this stands for secant. And the derivative of secant is these two. Secant's tangents. Isn't that nice? So the derivative of secant is secant tangent. But I could go backwards and read it as well. So the derivative of tangent, if I read it going this way, is secant times secant, which is secant squared. So we'll call that the pst rule. And guess what P stands for? Everything's positive. So down here, this C says we change the sign. We'll call this the rule. So and this C doesn't stand for cosine because we know already have that memorized. The derivative of cosine is what? Negative sine. So of course this C is not cosine, it's actually cosecant. So guess what the derivative of cosecant is? Well, there's 2 more C's. So the derivative of cosecant is these 2 C's, which is, oh yeah, the cosecant cotangent are the 2 more C's. And it's negative because it starts with C. But the nice thing is it goes backwards. The derivative of cotangent is what? Oh, well, those 2 C's, which stands for who? Cosecant squared. So you can kind of remember the pst rule and the rule. Again, I just come up with stupid things to try to remember I sing a song, or they're just memory tools. It's nothing mathematical. Do whatever works for you. But I like helps me. All right, find the derivative of this guy. Well, this is a product, so it says we got to use the product rule. And the product rule is 1. Just write down the function d2. Okay, here it comes. The derivative of cosecant. Let's see if you have it memorized. Oh, yeah, it's cosecant cotangent. And don't forget it's negative because it starts with a c. So 1 d2 plus, because the quotient rule was minus, but the product rule is plus 1d2 plus 2d1. If you don't know that, go watch a previous video. So 1d2 plus 2, oh, that's the cosecant function. And then d1, what's the derivative of secant? Oh, yeah, it's secant, and then it's something else. Well, the something else that goes with it is secant tangent. And that's my psst. Right? The derivative of secant is secant tangent. There's the S, there's the T. The question is, can I simplify anything? Well, looks like I can pull out a secant because that's common, and, well, frankly, a cosecant's common too. So let's see if we can pull out secant x cosecant x. I was thinking about maybe pulling out a negative, but not necessary. But I do have a negative cotangent, and maybe I'll write that second, just because it maybe looks a little bit nicer. So if the green and the yellow got pulled out, I'm just left with tangent. Now, that's a good answer, but I don't know. Maybe I could simplify it some more, because I know secant is really 1 over cosine, and this is 1 over sine. I don't know if I should try to switch to sines and cosines. We'll see. Just here, we'll spend just 10 more seconds looking at this. Cotangent is cosine x over sine x. And I'm just wondering what happens if I distribute this, because the sines will cancel, so I'm left with 1 over cosine squared minus, and if I distribute this, the cosines cancel, and that's 1 over sine squared x. I think that looks more simplified. Well, yeah, because 1 over cosine squared is secant squared theta, or x, minus cos. I wonder what the author did. This certainly looks pretty good. Yep, secant squared minus cosecant squared. So the burning question is, what would have happened if you would have left the answer blue? I don't know. It's up to me to figure that out when I grade it, but I would recommend you thinking about, I wonder if that simplifies. I wonder if Mr. Reynolds wants me to try to simplify. What's that final version that he wants this to be in? A second order derivative just means take the derivative of the derivative. You'll be okay with that. And then there's plenty more. So please go to Blackboard, download the worksheet, the PDF worksheet, print it off, and then go work through these problems. And I have worked out solutions here. So there's plenty of examples that you're welcome to work out. If you have questions, you can shoot me emails. Thank you.